Hello, Math 2 students. It's Mrs. Robinson. I'm here to work practice benchmark chapter 10 with you, so you can refer to this if you have questions. Um, this one is on the laws and properties of exponents, something you should have had a little bit of in pre-algebra. It may have been a while. I posted a laws and properties worksheet just to have you review all at once, all the properties in module 4 in Canvas. So go print that out, use it as a reference. Okay, let's start with number 1. Number 1 asks, hold on, I need a writing tool. Okay, write the expression using each base only once. So we have a writing tool that's not working. Hold on. Okay, in number 1, we are going to write the expression using each base only once. We have the same base here, -7, and we have a property of exponents that says if you have the same base, you can add exponents. So we're just going to go -7, and we add our exponents, -6 plus 7, and that will be -7. And I really need to put parentheses around this because if I don't, we'll talk about that in a minute, I actually have a different value. But -7 to the -6 plus 7 power will be -7. -6 plus 7 is 1, which just is going to be -7. Now, real quick, had I written it like this, -7 to the -6 plus 1 or plus 7 power, this would equal -7 to the first power true. And I would end up getting the same answer. However, if this for some reason was squared, -7 squared is different than -7 squared. This right here means -7 times -7. -7 is getting squared, which means +49. This right here, using order of operations, parentheses, then exponents. Please excuse my dear Aunt Sally. I do parentheses first, then exponents. So inside my parentheses, then I take it to the exponent. There are no parentheses here in this scenario. So I would do my exponent first, then I would multiply by what this is implying is a -1. So I would first square 7 and get 49, and then multiply by -1, and this answer would give me -49. So careful, these are two different things. -7 squared and parentheses, the whole quantity -7 squared. This means -1, basically, and then 7 times 7. This means -7 times -7, which gives +49. So be very aware of the difference between those two. It didn't matter in this scenario, but if you are squaring things, it will. Okay. All right, on to number 2. All right, number 2 is the same property. We have the same base. We have 3 different values here with the same base. So let's go ahead and use our property, same base. We add exponents. So this is going to be 3 to the 1 plus -2 plus 4 power. Well, 4 minus 2 is 2, and 2 plus 1 is 3. So I'm going to leave this as 3 to the third power. Even though I did finish this one out, they want us to write the expression using the base only once. So we leave it as 3 cubed. You don't need to finish that and write 27. That's how we want our answer to be finished. All right, let's look at number 3. What is the simplified form of each expression? So here we are going to simplify this. And let's go ahead and look at what we have. Now remember, when I have multiplication, multiplication is commutative, meaning if I write 3 times 5, that's the same thing as writing 5 times 3. The order doesn't matter in multiplication. You can switch the order around. So when simplifying something like this that has constants and variables and exponents, I like to rewrite the order around. All right, this negative I'm going to attach to the 4. So I'm going to write this as -4 times 6 times k to the -3rd times k to the 4th. It helps me work this problem a little bit easier since this is multiplied by this is multiplied by this is multiplied by this. It helps me work this easier because when I have the same base, I can add exponents, and then I'm just going to multiply my constants. So let's finish this out. -4 times 6 is -24. And then I have the same base here. I get to add exponents. So this is going to be k, and then -3 plus 4 is just 1, so k to the first. which is just negative 24k, and I'm finished. All right, on to the next one. I'm going to scroll up. Okay, number 4, we're going to find the simplified form of the expression. Give your answer in scientific notation. Now, just to review, scientific notation means you need to have your first number needs to be equal to or greater than 1 and needs to be less than 10. So your first number needs to be between 1 and 10, all right, less than 10. And then your second number is going to be base 10 to a power. So make sure when you give your answer, if you come up, when you multiply, if you come up with something like 25.9 times 10 to the second, for example, you might think I've done my multiplication. However, your answer is not in scientific notation because this number is not between 1 and 10. You need to move the decimal over once, 2.59 times 10, and then when you move the decimal to the left, you're actually moving it and making it smaller. So you need to make this bigger. You need to multiply by 10 to the third, all right? So just make sure you're doing that. Now let's clear that off. That is not that problem. So when we do scientific notation, once again, everything is multiplied. Multiplication is commutative. We can switch this around. This is 2 times 10 to the 6th times, the parentheses mean times 9 times 10 to the negative 9th. There are not addition signs here. We do not need to FOIL. This is all multiplied. Blah, blah. Anyways, it's all multiplied. So I can move this around. So I'm going to write this as 2 times 10, times 9. That's a 2. And then I'm multiplying these times, because they have the same base, I can add their exponents. All right. So I'm going to multiply my constants here. 9 times 2 is 18. And then I've got the same base here, so I can add exponents, just like I did with that last one. So I'm going to go 18 times 10, and then 6 plus negative 9 is going to be negative 3. Now, this is not in scientific notation because this number is not between 1 and 10. I need to move the decimal over once. This is actually 1.8. And because I moved the decimal over once, I need to add times 10 to the first power. Well, since I'm adding 10 to the first power, this actually becomes to the negative second, because this would be 10 to the first times 10 to the negative 3, and you add the exponents, this would be 10 to the negative 2. All right, and that would be my final answer. Okay, let's move on to number 5. Let's look at number 5, simplify the expression. We've got some fractional exponents, or rational exponents. Once again, everything is multiplied together, so I'm going to rearrange this in an order that works for me. I've got 6 times g to the 5/2 times 4 times h to the 1/2 times g to the 1/2 times 3 times h to the 1/8. Ooh, I'm going to put my constants next to each other so I can see how I'm going to multiply those. 6 times 4 times 3. Then I'm going to write my variables next, times g to the 5/2. And I'm not going to write h next, I'm going to write this g next. Everything is multiplied. This is all a big long string of multiplication, so I can change the order. Order doesn't matter when I multiply. All right, so I'm going to go g to the 1/2, and then I'm going to write h to the 1/4 and h to the 1/8. All right, now I'm going to go ahead and do my multiplication. Let's go 6 times 4 times 3. And that's going to give me 72. And then since I have the same base here, I can add exponents. Now, the beauty of this is when I have the same base and I'm adding exponents, these have a common denominator. Yay, because if they didn't, I would have to get a common denominator in order to add these exponents, but they do. They have the same denominator, so I can add numerators. So 5 plus 1 is 6. So this is going to be g to the 6/2. Now 6/2 reduces. 6 divided by 2 is 3, so this is actually g cubed. All right, so I'm going to write this down here, 72 times g cubed times, and then once again I have h and h, and I have the same base, so I get to add exponents. Now these do not have the same denominator, so because I'm adding exponents, this is h to the 1/4 plus 1/8. I need to get a common denominator. So if I want to add 1/4 and 1/8, the common denominator of 4 and 8, well, 4 divides evenly into 8, so their common denominator is going to be 8. What times 4 gives me 8? 2. So that means I need to multiply the top and bottom by 2. 4 times 2 gives me 8. 1 times 2 gives me 2. So 1/4 is the same as 2/8. If I reduce this, I get back to 1/4. And I'm adding, now the denominator is already 8 here, so I don't need to change the numerator. And then 2/8 plus 1/8 is 3/8. And there I'm finished. So when I have the same base and I add these exponents, 1/4 and 1/8 is 3/8. So this is going to be times h to the 3/8 power. And there we are finished. Okay, on to number 6. All right, number 6, what's the simplified form of this expression? All right, this is our property where we have a power raised to a power. So when this happens, it's a multiplication, not an addition. So this is going to be y to the 3 times 2, which is 6. If you ever want to check that out, write this out. What does this mean? Y cubed means y times y times y. That's what was inside the parentheses. Y times y times y, and I'm doing that 2 times, okay? So if I have y times y times y 2 times, that's going to be y times y times y, that's 1 time. And here's the second time, y times y times y. So how many y's do I get? 1, 2, 3, 4, 5, 6, y to the 6, all right? Y to the 6. All right, once again, what's the simplified form of this? Same property. You have a power raised to a power. You multiply exponents. It's harder to work this out when you're dealing with fractional exponents than when you're dealing with whole numbers. So let's just use the property. Y to the 3/4 to the 1/3 power, that would be y. I multiply these. When you multiply fractions, you multiply straight across the top and straight across the bottom. So this will be 3 over 3 times 4 is 12. Now I can reduce this fraction. 3 goes into 12 4 times, so this will be y to the 1/4. And you're finished. All right, let's go ahead and go over number 8. What's the simplified form of this? Now we've got a little bit more work here. Remember with order of operations, please excuse my dear Aunt Sally. You want to do parentheses first and then your exponent. So you've got this in parentheses. You want to raise this to the exponent before I start working with this. So I'm not going to go p to the 5th, p to the 9th, same base, add exponents. I cannot do that yet. That is a multiplication. I do multiplication after I do exponents and parentheses. So make sure you do your order of operations first. I've got to raise a power to a power to get rid of this parentheses first. So I've got to do this. So this is going to be p to the 9 times negative 8. Well, if you do 9 times 8, well, it's going to be, 9 times negative 8. I'm going to get negative 72. So this is going to be p to the 5th times, I'm doing this property, this is going to be p to the negative 72. Now that I've done this with my order of operations, I've done my parentheses and my exponent, now I do my multiplying. So my multiplying is same base, add exponents. So I'm just going to go 5 minus 72, or 5 plus negative 72, and that's going to give me p to the negative 67 power, and you're finished. All right, let's scroll down. All right, looking at number 9, it asks you what is the simplified form of this expression. So with our properties of exponents, these are kind of fun. You just got to know the rules. So let's just work this one. We've got 5 times k to the 11th cubed. Now, when I have more than one thing in here cubed, you have to remember the rule. I have to cube each thing. I don't just have one base. I have 5 here. So this is actually equal to, remember with our order of operations, parentheses, exponents, multiply, divide, add, subtract. I forgot my add. Please excuse my dear Aunt Sally. All right. So I need to make sure that I do this in order. I'm going to do my parentheses and my exponents. All right. With my exponents, I need to realize that I'm cubing this whole thing. So if I wrote this out cubing it, it would be 5k to the 11th times 5k to the 11th, times 5k to the 11th. That's doing that 3 times. And now everything is multiplied. I don't have an exponent. I can just do, I did my exponents. Now I can do my multiplying. I can multiply this. This is 5 times 5 times 5. And this is k to the 11 times k to the 11 times k to the 11. Because order doesn't matter with multiplication, I can rewrite this. So this becomes 5 cubed. And then these all have the same base, so I add their exponents. This will be k to the 11 plus 11 plus 11, which would be k to the 33rd power. Now looking at this, this is the same as if I were to take this and make sure 5 is cubed, and then 11 is a power to a power, which means I multiply this. So this would be 5 cubed, and then k to the 11 times 3, which is 33. So that is the shortened version of writing it all out. Just make sure that both of these get cubed, not just the k to the 11, which is what happens a lot. So you cube the 5 and then cube this. Now 5 cubed, I actually can get a number for that. 5 cubed is 125. So this is 125k to the 33rd power, and you're finished. On to number 10, let's scroll down. All right, we got to do the simplified form of this expression. I love properties. These are kind of fun to play with. All right, once again, that same property. I'm going to make sure I take 2 and take that to the 4th power, and then x to the 5/2 to the 4th power, and then this x to the 5th is to the 3rd power, and then I can start doing my multiplication. So I've got to do my exponents first. Please excuse my dear Aunt Sally, parentheses, exponents, then my multiplying and dividing. All right, so let's do that. So I'm going to take this. This is going to be 2 to the 4th power. Make sure you take both of these to the 4th power. And this is x to the 5/2 to the 4th power. Remember, a power to a power is a multiplication. Okay, so if I multiply 5/2 times 4, that's the same as 4 over 1. So I can multiply straight across the top and straight across the bottom, or I can cross cancel to make it easier. 2 goes into 4 2 times. 2 goes into 2 once. So this is 5 times 2, which is 10 over 1, or just 10. So multiplying these, I'm going to get x to the 10th power. So 2 to the 4th power, multiply these, x to the 10th power. Now let's come over here and work this. This is all multiplied times. This is a power to a power, so I multiply. This is x to the 15th power. You got to know your properties to do this, all right? Now I've done my exponents. Please excuse my dear Aunt Sally. I did my parentheses, my exponents. Now I get to multiply and divide. So multiplying these, 2 to the 4th power, once again, I do have more exponents. This is like multiplying 2 times itself 4 times. So 2 to the 4th power is going to be 16, okay? And then multiplying here, same base, I add my exponents. This is going to be times x to the 25th. 16x to the 25th, and you're finished with that one. All right, let's go on to number 11. Number 11, using our properties. What is the simplified form of this expression? Now, we also have a property. When you have the same base and you have a division, you subtract exponents. Now, a great way to show that is if I were to write this out, this would be 14 n's. That's going to take forever. Let's do a simpler. Let's do n to the 5th divided by n cubed. This would be 5 n's. 5 n's, and this would be 3 n's. And since these are all multiplied, I can cancel out multiplications. So 1 n divided by 1 n, that leaves me with 1 on top and bottom. 1 n divided by 1 n, 1 n divided by 1 n, and I'm left with 2 n's on top and a 1 on bottom. The 1 you don't need to write on bottom, so this is just n squared. Now the property is n to the 5th over n cubed says same base, subtract exponent. So this would be n to the 5 minus 3, which just gives me n squared. And I don't have to write this all out. So let's use our property. Our property says same base with division, I subtract exponents. This is be n to the 14 minus 8. Which gives me n to the, what is that? 14 minus 8 is 6. Yes, and you're done. All right, on to the next one. Now, when you get these negative exponents in here, things get a little trickier. A couple ways to look at this. When you're simplifying something, anything to the negative power means you're going to take 1 over. So this would be 1 over b to the 10th. We know b to the negative first power is 1 over b. B to the negative 10th power is 1 over b to the 10th. So I could do that, and I could say, well, this is actually 1 over b to the 10th. And by doing that, it actually bumps it to the bottom. So instead of a to the 4th times 1 over b to the 10th, I can just take this negative exponent and bump it down to the bottom of my fraction and make it b to the positive 10th. Now, because this is on the denominator, this is actually 1 over b to the negative 15, and this is tricky. This is actually b to the negative 15 equals 1 over b to the 15. So this is 1 divided by 1 over b to the 15. Now, when you have a fraction divided by a fraction, you keep, flip, change. KFC. Keep the top, flip the bottom, change the divide to multiply. Okay, so that becomes 1 times b to the 15 over 1, which is just b to the 15. Because 1 over 1 times b to the 15 is just b to the 15. So this on the denominator actually can be brought to the numerator and become b to the 15. So here's what I do whenever I have negative exponents with fractions. If the negative exponent is on the top, I bring it to the bottom and make it a positive exponent. If the negative exponent is on the bottom, I bring it to the top and make it a positive exponent. So really you just have to flip it to the bottom or flip it to the top to get it to be positive. So let's push this to the bottom. This will be b to the 10th down there on the bottom. And push this to the top. This will be b to the 15th up here. All right, so now what we have is a to the 4th, and now I don't have to deal with subtracting negatives. There is multiple ways to do this problem. Okay, so since I have multiplication here, I can do that in a variety of ways. The same with division, okay? So what I'm going to do is I have the same base. I'm going to subtract these exponents. Or I can think of it like this, a to the 4 minus 12. Okay, that's going to give me a negative exponent. That's going to be a to the negative 8 if I subtract these. Or I can say there are 4 a's on top and 12 a's on bottom. So these 4 a's are going to cancel into these 12 a's and leave me with 8 a's on bottom. Now a to the negative 8 is the same as 1 over a to the 8. So it is 8 a's on bottom. Now this one you could go b, same base, subtract exponents. This is 15 minus 10, which will be b to the 5th power, okay, which is on top. Or I could say there's 15 b's on top and 10 b's on bottom. 10 b's on bottom divide into 15 b's on top and leave me with 5 b's on top. So what I'm left with is 5 b's on top and 8 a's on bottom. Now if I had done it like this, I would have 1 over a to the 8th times b to the 5th, which equals b to the 5th over a to the 8th. And I would have the same solution. There's multiple ways to do this problem. Just make sure you know your properties. Okay. All right, on to the next. Okay, so Lake Ontario is the smallest of the Great Lakes with the surface area of 7.34 times 10 cubed miles. This should be a little boo-boo here. This should be miles squared because we're dealing with area, not volume. All right. So with surface area of 7.34 times 10 cubed miles squared, the surface area of all 5 Great Lakes is 12.8 times the surface area of just Lake Ontario. What's the surface area of all 5 Great Lakes? So if we just have Lake Ontario and then we got 4 other lakes, all right? So all 5 is going to be this many times just Lake Ontario, just this lake. So we're going to take this lake, its surface area, and we're going to multiply it by 12.8, and that will give us all the lakes. So let's go ahead and go 7.34 times 10 cubed, and it is miles squared, times 12.8, And we're going to go ahead and figure out what our surface area of all the lakes is. So we're going to multiply. Since this is all multiplied, I'm going to go ahead and multiply my constants, and then I've got a base of 10. So I'm going to multiply 7.34. Multiplication is commutative, it doesn't matter the order. So I'm going to go 7.34 times 12.8. I'm going to do that on a calculator. 7.34 times 12.8. That gives me 93.952. And I still have to multiply that times 10 cubed. So this times this times this times 10 cubed. Now my answer isn't quite in scientific notation yet. And it doesn't say to put it in scientific notation, but I would like you to put it in scientific notation because that's how it will be on the test. Go ahead and move the decimal over 1 decimal place. Okay, so I'm making this number smaller, which means I'm going to have to multiply by 10 to the first to accommodate for that decimal place. 9.3952 times 10. When I move it over 1, this becomes 10 to the 4th. And that would be miles squared. And that should be your solution. That would be the surface area of all 5 Great Lakes. All right, we got to find the simplified form of this guy. We've got a fraction here and we're cubing it. So just like our rule, when I multiply two things and I cube it, when I divide two things and I take it to a power, I have to take each thing to a power. So this is going to be 1 cubed, which is just 1, over 4j to the 5th cubed. Now this whole dilly-bob here needs to have two things cubed because I have a multiplication problem just here on the bottom. So basically when you cube a value like this, you cube everything. So 1 is going to be cubed, which is just 1, and I'm going to write that as just 1, over 4 cubed, and then j to the 5th cubed. Remember, a power to a power, you multiply. So this would be j to the 5 times 3 is 15 power. Go ahead and simplify that. 4 cubed is going to be 4 times 4 times 4. So I'm going to get 64 times j to the 15th power. And that would be most simplified, and you're done. All right, what's the simplified form of this expression? B to the 5th, 3n to the 5th to the negative 2 power. Now, there's a little trick you can do with this. You could do this two ways. You could multiply this by 5, go ahead and distribute your parentheses, or excuse me, your exponent, and do this to the negative 2 power, this to the negative 2 power, this to the negative 2 power. When you're dealing with a negative power, you're basically flipping everything, okay? Because it's going to be 1 over whatever you have to the power. So by doing that, I can change this to a positive power right away by flipping this fraction. This is going to become 3n to the 5th over b to the 5th. Flip the fraction and then take it to the positive 2 power. A little trick for your properties of exponents. Instead of doing everything and then having to flip each thing individually, just flip the whole fraction, then take it to the positive 2 power. Now go ahead and work your problem. Each thing needs to be raised to the 2nd power. So this is going to be 3 squared, and then n to the 5th squared. A power to a power is a multiply rule. So that's n to the 10th over, and then this is a power to a power. I have to take this squared too. So b to the 5th squared, a power to a power is a multiply. That's going to be b to the 10th. So 3 squared is 9, n to the 10th over b to the 10th. These are not the same base, so they don't reduce anymore, and you're finished. All right, little tricks there. Dealing with fourth roots here for this one. Now, a couple ways you could do that. Since you're taking the fourth root, you want this to be something to the 4th power. You could break down 81 into primes. You know 81 is 9 times 9, and then 9 is 3 times 3, and 9 is 3 times 3. So this would be 3 times 3 times 3 times 3, or 3 to the 4th power. By breaking it down into its primes, you can see this will be the 4th root of 3 to the 4th. The root and the power cancel, and that's going to give you 3. You can check this on a calculator. You can do a fourth root. If you have a phone calculator and you check your phone calculator out, if you tip it to the side, you have roots. And if you look at your roots, you have one that is a y root x, which means you can plug in any root you want for that one. So in this case, I would do 81, then I click y root x and I click 4, and it gives me 3. So you'd have to do it in that order. Different calculators have different orders of entering things. This one would look like this on a phone calculator, 81. Then you would hit this button, y root x. Then for the y, which would be 4, then you would hit 4 and then enter. That would be the order that you would put this to get this solution if you wanted to use that. You cannot use this calculator on the final exam, however, so make sure you know how to do it on a scientific calculator, and different scientific calculators have different enterings. So you can always try a simple problem that you know the answer to make sure you know how to enter it correctly. Okay, that's how you try it out. All right, write the exponential expression in radical form. So once again, we're dealing with rational exponents or fractional exponents. And I always say this with your fractional exponents, this is how you remember. Powers are high, roots are in the ground. So the bottom number is the root, it's in the ground. Powers are up on high. That's how you remember the top number is the power and the bottom number is the root. Roots go in the ground. So this would mean 5. 5 isn't raised to this power, just the x. If 5 was raised to that power, you would have this here, but you don't. So let's undo that. All right. So this will be 5 times, my root is 4, my power is 5. 5 times x to the, or excuse me, 5 times the 4th root of x to the 5th. You may also write it like this, 5 times the 4th root of x and the whole thing to the 5th. Now, either of these will give you the same solution. It doesn't matter if you do the 5th power and then the 4th root, or if you do the 4th root and then the 5th power, you will get the same solution. So either of those are correct. And let's move on to number 18. Let's look at this one. Write the expression in simplified radical form. Now this one, it does have the parentheses around it. Unlike this one where only x was to the 4th power, this one, the whole thing is to the 1/2 power. Now, you should be able to recognize 1/2. The power is 1, the root is 2. That's just the square root. That's all this is. So we're going to do the square root of 36x. Okay, and you don't need to write a 2 with the square root. It just is the square root, okay, when there's nothing written there. All right, so the square root of 36, I know 36 is 6 squared, so I can pull this out of the root. It's just 6. I square rooted this. The x is not squared, so it needs to stay in the root. So I pulled this out, I square rooted it, it becomes 6, and the x stays in the root. And that will be your solution. All right, on to number 19. I need to write the expression as a power with a rational exponent. Rational means a fraction. Things that are rational can be written as a fraction. So this means your fractional exponent. And I always say it's rational because if I can write it as a fraction, it's rational. If I can't write it as a fraction, it's a decimal that goes on forever and doesn't repeat or terminate. That's irrational. I just go on forever irrationally. Blah. Okay? But rational means I can be written as a fraction. Let's go ahead and work this one. This is the 4th root, and b is to the 5th power. However, 256 is not to the 5th power. So if I was going to write this as rational exponents, those are fractional exponents, I'm going to write 256. And my exponent here is 1 since nothing is written. So this will be to the 1/4 power times b. And then the power is 5. The root is 4. All right. Now this would be finished except for I can reduce this. 256, I know 4 goes into 256. Let's see if this is 4 to the 4th power, because if it is, then I can work this out. If I do 256 and divide it by 4, I'm going to get 64. Oh, it is. 64 times 4, and then 64, I can break that up. If I divide 64 by 4, it's 16, which is 4 times 16. And then I know 16 is 4 times 4. So that is 4 times 4 times 4 times 4, or 4 to the 4th. So if I take the 4th root of 256, I'm going to get 4. So the 4th root of 256 is 4 times b to the 5/4 power, and that will be your solution. Let's go ahead and look at number, and that's not written very clearly. Let's undo that. That should be 5/4. That's what that says, 5/4. I didn't write that very well. Okay, let's go ahead and clear that out and pull down to number 20, reasoning. Now, this was a lot of just practice in, do you know your properties and your laws of exponents? There weren't a ton of word problems on this set or even in this chapter. So I'd like you to know your reasoning and make sure you understand these properties. So on the test and on the practice test, when it says show why you add the exponents when multiplying, tell me, you have the same base, you add exponents, why? Show me. So here's what I'd like to see. I'd like to see because, I need a pen, because you would say something like this. 4 cubed means 4 times 4 times 4. And 4 to the 4th means 4 times 4 times 4 times 4. And when you have the same base, you add exponents, because this would be 4 times 4 times 4 times 4 times 4 times 4 times 4. And that would equal 4 to the 7th. So I would like to see this written out so I know that you know what this means. And you would say something like, because the base is 4 and the exponent tells me how many times to multiply the base. It tells me to multiply 4 by itself 3 times. Here it tells me to multiply 4 by itself 4 times. So when I add these all together, I get 4 to the 7th. And I want to see this. This is what I want to see, so you can show me what this means and what this means and what it means all together. This is what I'd really like to see. All right, that is it for the practice benchmark chapter 10. Good luck. Email me if you have any questions. Make sure you print out that property sheet that I posted in module 4. Go over it, make sure you know it, and good luck and have a great day.